Good day, everyone. We are Group 5, and this is our final presentation for modified SAP 1 rotate left. So, the simple as possible SAP 1 represents the beginning of the development of modern computers. Its structure explains the fundamental structure of a microprocessor. The SAP 1 illustration is shown in the figure. The SAP1 computer's instruction format is XXXX and XXXX, which is the OP code, is made up of the first 4 bit and the operand is made up of the final 4 bits or the address. The following structure are part of the instruction decoder. Number 1, LDA 000, the load address memory content into accumulator. Number 2, add 0001, add addresses memory content to accumulator. Number 3, sub 0010, subtract address memory content from accumulator. Number 4, out 1110, load accumulator data into the output register. Number 5, halt 111, stop processing. Number 6, ROL or roll 1011, rotate on left instruction. Each instruction has a dedicated 6 T-states in SAP1, 3 fetch and 3 execute cycle. Not every instruction needs to be executed in each of the 6 T-state. The T-state that is not in use is designated as a no operation or NOP cycle. For SAP1, each T-state is referred to as a machine cycle, which each falling edge of the clock falls. A T-state is produced by a ring counter. Following the 6th T-state, the ring counter output is reset. The fetch cycle, T1, the T2, and the T3 machine cycle, and the execute cycle, which is the T4, T5, and the T6 machine cycle. The experiment design and simulation were performed using Logism software. Circuit diagrams were designed for each component and then combined as a single unit using buses. Moreover, a circuit designed for the rotate left operation was created and integrated into the SAP1 system. So we will present our logism of SAP1 rotate left.
SAP1's primary objective is to introduce all the fundamental concepts behind computer operations, including an understanding of how memory interacts with other systems components like the input and output. The SAP1 consists of the following components, which are program counter, input and MAR, 16 by 8 RAM, instruction register, controller sequencer, accumulator, adder subtractor, B register, output register, and binary display. First is the program counter. Program counter comes from 000 to 1111 and signals the memory address of the following instruction to be fetched and executed. It is a component of the control unit. Just before each computer runs, it is reset to 0. As soon as the computer starts up, the program counter sends address 000 to memory, where it is then increased to 0001. If you click the clock, it will cycle through the increment the counter value on every falling edge. It is also allows one to change the current value for a new one and points to a location in RAM where the next instruction to be executed resides. The input and MAR block are located below the program counter. The address and data switch registers are part of it. The SAP1 memory includes the MAR. The address in the PC is locked into the memory address register while the computer is running. Next is the RAM, or the random access memory. Here are stored the data and program code for the SAP1 computer. The RAM receives 4-bit addresses from more during a computer run, and a read operation is carried out. Thus, the instruction or data word from RAM is transferred to the W bus so that it can be used by another component of the computer. It is a synchronous RAM, thus as soon as a valid address and control signal are provided, the output data becomes available. 08, B0, E0, F0, 40, and 08 is placed into the memory for this modification. Zero eight is for the zero is for the command, and 8 is for the position in the memory. While B or 1011 is the command to trigger the rotate on the left, and 0 is the position. E0 is to trigger the out or the output for the data. F0 is to trigger the help to stop the process. Lastly, 8 or 04 is the data that will undergo the rotate on left process, which this can be any number.
So next is the instruction register. So the instruction for the SAP1 computer is contained in instruction register. So it is responsible for fetching and decoding instructions from the RAM and changing the control flags in order for the processor to execute the instructions. Each instruction the decoder is aware of is listed in the instruction set together with information on which flags are enabled at each stage of the instruction execution. After the instruction register, let's proceed to the controller sequencer. So, for the controller sequencer, it erases the most recent instruction from the instruction register and resets the program counter to 0000. It creates control signals for each block to ensure that actions take place in the appropriate order. The SAP1 computer's entire operation is synced using the clock signal. Next, the accumulator. So for the accumulator, it is an 8-bit buffer register with two outputs for holding findings during a computer run. The W bus receives the two-state output. As a result, the other subtractor is continuously driven by an 8-bit accumulator word. When EA is high, the identical word can be heard on the W bus.
So next one is moving on. A2 A2's complement other subtractor is an other subtractor. Its contents may vary as soon as the input words change because it is asynchronous or unclocked. The other subtractor will not participate in the operation of shifting all bits to the left and moving the most significant bit into the least significant bit position for this modification. Next one is the B register. It is an 8-bit buffer register. It is generally used to store the second operand of mathematical operations. The first operand is always the accumulator. The other subtractor is driven by the B register's two-state output, which draws the number to be added or subtracted from the accumulator's contents. And the next one is rotate on the left. Rotate on left. The abbreviation or ROL or roll stands for rotating the input data to the left. So the most significant bit will be moved into the least significant bit position and all bits will be shifted to the left by the instruction. The appropriate operation code is 1011. And lastly, we have here the output register. So for the output of the out command is stored in the output register because processes data can exit the computer through this register. It is frequently referred to as an output port. In this modification, since the input data from DRAM is 0001000 or 8 in decimal, the output of the binary display, a row of 8 light emitting diodes to show the contents of the output register should be 0001, 0000, or 10 in hexadecimal that will be shown on the hex digit display.
Next section is the results and discussion, and the findings demonstrated that the SAP1 system may be upgraded to include new operations. So in this case, a rotate left operation was used and it was successfully implemented into the system and functions as intended. So first, we would load 000 1000. And then, as you can see here, bits are shifted 1 unit to the left, and the most significant bit is successfully added to the last significant bit, resulting to 0001 0000. Next is the modified SAP1. First, content should be first loaded to the RAM. And as illustrated here, the operations to be used are load, rotate left, output, and halt with their corresponding opcode. So, okay, so all major components of the modified SAP1 are functional, and the clock and clear buttons also work normally. So clock can be toggled manually by clicking the clock button or using the ticks enabled in the simulate part. And for the clear operation, the button should be toggled and it is working normally. And thus, the resulting output of the rotate left operation was successfully displayed in the output register and binary display. So based on the given input, the binary digit to be used is 0001000, which is 08H in hex code. And after the rotate left operation, the binary digit results in 0001 0000, translating to 10H. And the output is shown in the simulation under the binary display and the output register using the LEDs. And that is Group 5 presentation on modified SAP1 rotate left.